Okay, so on that last video, it's called direct variation, not direction variation. That was a mistake in the typing, and I didn't notice it till I got the video all done, but I'll have to fix that later. But it's called direct variation. Now we're going to talk about inverse variation, and sometimes they'll say inversely proportional to or varies inversely, something like that. But you're going to see the word inverse in there, and that's how you know it's inverse variation. I think of inverse variation like this. Say you live in Alaska and you own a parka store where they sell parkas, okay? And you find that as the temperature goes down, so we're selling parkas in Alaska, and you find as the temperature goes down, as it gets colder, your sales go up. That's an example of inverse variation then. And the model for it is y equals k over x. Okay? Sometimes they'll write k times 1 over x, but this is fine. And again, k is that constant of variation. The number of hours it takes for ice to melt varies inversely with air temperature. So you've got time. They usually use a lowercase t for time, or you could use h for hours. They don't tell us the variables. And it varies inversely as air temperature. They usually use a capital T for temperature. So, okay. But if you don't like using little t and big T, you could use H for hours and A for air temperature or something like that. Okay, but I'll go with what I've got, little t and big T. So it says write the equation of variation. So little t, the number of hours it takes for ice to melt, is going to equal K over big T, the temperature, the air temperature. Okay? Now, part B, we have to figure something out. How many hours would it take for the same block of ice to melt if the temperature was 78 degrees? In order to do that, this is the answer for the first part A. But in order to do part B, we have to figure out K. They don't really tell you that. But you're going to have to figure out what K is. That is based on this right here. Maybe they do want us to put K in for the part A. Well, we're going to figure it out right now. So it takes 2 hours for when the temperature is 65. Okay? So then to solve that, you would multiply both sides by 65. And so you get 130 equals K. So now I'm going to rewrite my answer to part A. I'm going to say little t is equal to 130 over large T, capital T. So maybe they do want you to figure out the K. All right. Sometimes they ask for it separately. So I was a little surprised the variation problems were in here. But okay. So now we have an equation. T, temperature or time, equals 130 over the temperature, the air temperature. So now part B says, how many hours would it take for the same block of ice to melt if the temperature was 78 degrees? So little t, that's what we're looking for, time, is going to be 130 over 78. And then we're going to get probably some decimal for this. Let's see what we get. 130 divided by 78. Yeah, so it's going to be 1.7 hours. Now, that's approximate. I've rounded that off. My calculator says 1.6666, like that. So sometimes they'll tell you, okay, we want it accurate to the nearest tenth or round it off. I don't see anything that says that in this case. So I would just put 1.7. I know it's going to make a difference in WebAssign. You could write it as a fraction. It'd be 1 2/3 hours. which you could change that to 1 hour and 40 minutes if they wanted it that way. So you just kind of have to play around with that, how they tell you they want the answer. So, okay, that was that one.